We break it down into 5 detailed steps. Step 1. Set up the tripod. Loosen the fixing screw. Stretch to the appropriate height, generally chest level. Tighten the screw. Placement of the 3 leg supports. It is related to the position we observe. If we observe this direction, when we set it up, try to keep your body facing this direction. Place the leg cross at your sides, so when we observe, it's less likely to encounter this leg cross if we observe in this direction. That's roughly how it is set up. When setting it up, 1 is to roughly ensure the level of the rack head. Let's take a look at the second one. Is it directly above this control point? Then place the instrument on the rack. These 3 corners are the same as the 3 corners of the rack. It corresponds. Don't go astray. Additionally, the base has a thick, flat air bubble. This thick, flat bubble is usually placed in front of the observer. This horn. This makes it easier for us to level them later. After straightening, tighten the connecting screw. Note that before tightening the connecting screw with your left hand, you always have to hold the handle to prevent it from falling. The second step is to align the center. Turn on the device and turn on the laser. At this point, adjust the 2 leg supports. Make sure the laser point coincides with the exact center of the control point. Achieve rough alignment. After overlapping, be sure to step on the leg of the shackle. Make sure to firmly step on the 3 leg supports. At this point, we will notice the position of the laser point shifted. If it were on flat ground, on cement floors, the offset is relatively small. It may be larger on land. Now, let's move on to the third. Conduct precise alignment. Precision alignment is achieved by adjusting the foot spiral. Make the laser point. It coincides with the exact center of the control. The fourth part is rough and flat. There is a round, flat. At this point, extend and adjust the height of the 2 leg supports. Let's make the thick flat bubbles larger in the center. When adjusting, we need 1 hand at the tiger's mouth position. Hold one side of the leg crossing. Tighten this spiral. This makes it less likely for the instrument to slip. Look at the bubbles. We start lifting the leg cross, and the bubble is moving toward us. If you lower it, head toward the opposite side. At this point, we adjust the bubbles to the leg crossing. Maintain consistent direction. Tighten the screw and adjust the leg support. Let's adjust the other leg support. We stretch the height of the second leg to center the bubble. If it's not centered, we adjust the first leg support again. Let it stay in the center. Step 5. Perform the finishing level. This is the tube bubble leveling. Adjust the tube bubbles to a position parallel to any 2 foot spirals, both inward and outward simultaneously. Adjust the foot spiral to center the tube bubble. The adjustment process must be steady. Once the center is stabilized, rotate the instrument 90 degrees. Make the side of the theodolite perpendicular to the line connecting the 2 foot spirals. At this point, adjust the 3rd foot screw again. Center the tube bubbles again. When adjusting, it's the same. Be slow and steady. After the second direction is centered, we return to the first face. Check if the bubbles in the tube are still centered. Both sides are in the middle. This means our jingping is no longer an issue. Finally, we need to check Check if the lower laser spot is still at the center, if not in the center. At this moment, loosen the connecting screw. Push the instrument flat. Align the laser dot. At this point, the offset is usually very small. We just need to push it flat. That's it. Do not rotate this machine base. After overlapping, be sure to check again. Is it still in the middle? If not centered, we still use the precision leveling method for adjustment until the bubbles in both directions are centered. The exact center of the laser point and the control point coincide. Our setup was thus completed. Focusing the theodolite. We break it down into several steps. Step 1. Aim the telescope at bright targets like the sky. Adjust the eyepiece focusing screw. Continue until the crosshairs inside reach their clearest state. Step 2. Through a coarse sight. Aim at the target. After aiming at the target, and those nearby locked him tight, tighten the fixing screw. Aim up and down, and locked him tightly. All have screwed inner rings and large brake screws. Step 3. Adjust the telescope's focusing spiral. This sets the internal target to the clearest state. Step 4. Fine-tuning. Fine-tuning the level. The outer twist is the twist. Those around him were slightly distorted. Vertical fine-tuning, causing slight movement up and down until the center of the 10 threads. It coincides with the exact center of the goal. Step 5. We need to move up and down. Moving left and right. Take a look. The very center of the crosshair. Is it centered on the target? Positional shift occurs. If a position shifts occur, we recalibrate. Telescope focusing spiral and eyepiece focusing spiral all the way to the top, bottom, left. No position shifts occur. Let's continue. Readings and observations. Hello everyone. The theodolite is mainly used to measure the horizontal angle between 3 points, or vertical angles in the vertical direction. We made 3 points for the demonstration. Point 1, point 2, and reference point. We set up the instrument at a reference point, observe the other 2 points, and thus measure its angle. Let's first look at the 2 points we have done. This is the first point we made it, marked as 1. This is the second point we made, marked as 2. First, let's use the theodolite. Aim for the first target point. First, take a rough look. Fine-tune again, aim precisely. After aiming, let's look at our aiming. After aiming, click, set to 0. Level, will flash. Press, set to 0. At this point, turn that direction. Set to 0 degrees 0 minutes 0. Let's aim for the second direction. Aim in the second direction. Start with a rough aim. Rear focused on precise sights. Check out the aiming effect. At this point, the display level on the horizontal display is 51 degrees 5 minutes 17 seconds. It is formed by 3 points. Horizontal angle. The video above explains the setup and leveling of a theodolite. There is also focus and aim. Let's talk about its specific uses. The theodolite is mainly used for angle measurement. This refers to measuring the horizontal and vertical angle. This isn't very clear. We can give some examples. In actual construction, there are mainly 2 types of uses. The first is in our room engineering. Let's look for the 90-degree angle, or a 45-degree angle, a 60. This is a type of usage. Another type is our steel structure, glass and wood walls, or you could erect a wire root. When standing upright, these steel structures are, or rather, a pole, vertical and vertical are used in this usage. Now, Let's demonstrate it in detail. Category 1. We are here. When building a house, look for this 90-degree. That's how I came to find. Arrived at the scene. The client will definitely give us at least 2 known. He will mark it on the drawings, and he will tell you on the spot that this is the first known point. That's the second known point, and it will tell you the actual location. Then you need to set up the theodolite at the first point, leveling the center, then aiming at the second known point. After aiming, rotate the theodolites left and right. Locked. After locking, let's perform the reset to 0 operation. After setting the remainder, now we need to turn on the brakes. Start rotating the theodolite. Rotate about 90 degrees. Then lock the brakes. Then start fine-tuning. Through fine-tuning, adjust the theodolite's degree to 90 degrees 0 minutes 0 seconds. At this moment, it points in this direction. This is the 90-degree angle. The first and second points, the 90-degree angle between them. At this point, the blueprint usually tells us which building this is. You need to build 50 meters, or maybe build 80 meters. Then use a steel tape measure to start from this point. Following this direction, the direction indicated by the stretch a distance of 50 meters, or rather, a distance of 80. You find the third point. Other points are found this way. This is also called a simple formula. If the drawings you have are very complex and require you to lay out the layouts for the bidding, obviously, using a theodolite and a steel tape measure is exhaustive. At this point, you might need an RTK or a total station to set up the layout. This is the first type of use. The second type of use is in glass, wood, walls, and steel structure. And the standing is the vertical of the project bid. Let's do a demonstration. Using this utility pole as if we erect this utility pole, this is how it is operated. First, we definitely need to set up the theodolite and level it. After leveling, we first aim roughly with a telescope. Then aim for its bottom. Use a crosshair in the center. Aim at the bottom of this pole. Lock the left and right sides of the theodolite. It can rotate up and down, and the theodolite can still rotate up and down. Now, the direction it is observing up and down, definitely vertical. Now, let's observe the crosshair inside. Look up at the upper or middle part of the lever. See if it's on the vertical line of this crosshair. If it deviates from the vertical line, so we need to direct the construction or pole support personnel to make adjustment. Ensure the entire construction process is vertical. This is the second major usage.